Hello everyone. Today in this video we will be studying the subtopic of dative bonding, which is basically a part of chemical bonding. Now dative bonding is also known as coordinate covalent bonding, and in that basically there are shared pairs of electrons which are provided by only one of the bonded atoms. Now by bonded atoms we mean that one atom will be a donor of electrons and the other will be an acceptor of electrons. When a dative bond is formed, they will basically display the characteristics as that of a covalent bond. So even though it's a different type of bonding, the chemical properties will somehow remain the same as that of a covalent bond. Now, in dative bonding, for it to take place, the donor atom must have at least one lone pair of electrons, and the acceptor atom must have at least one vacant orbital in its outer shell for this bonding to take place. Now, to see how this gets inculcated in chemical reactions, we will be looking at 4 examples to make sense of this theory. The examples are as following: acid dissociation, neutralization reaction, Al2Cl6 dimer, and dissociation of water. In this video, we will be covering the first 2 examples. Now, acid dissociation. An example that we can take is of hydrochloric acid. When dissolved in water, they would dissociate into H positive ions and Cl minus anions. Now, we already know as a fact that HCl is polar, right? So, when HCl and H2O are added to each other, they would chemically combine, and what actually happens is, okay, instead of the H plus ion we get the H3CO plus ion, which is the hydroxonium ion, right? So let us label this. It is the hydroxonium ion. Now the hydroxonium ion, how that is basically formed, this is a result of dative bonding. Now let's look into it. First, due to electronegativity, we know that the oxygen of the water molecule will be more electronegative, so it will get the delta negative sign, and these two can get the delta positive sign. Now what actually happens is, okay, even in HCl, Cl will be the more electronegative atom, so it will get delta negative and this will get delta positive. Now we can see that the oxygen has a delta negative charge and the hydrogen of the HCl molecule has a delta positive sign. Now the oxygen will basically have two lone pairs, we already know that, as it's in its nature. What happens is the oxygen will pull the hydrogen, it will attract it due to the electronegativity difference, and the two bonded atoms over here of the covalent bond both will go to the chlorine atom. So the bond of the HCl will break and the electrons of the bond will go to the chlorine atom, and the hydrogen of the HCl molecule would be pulled towards the oxygen of the water molecule. Now these curly arrows are representative of movement of two electrons. Okay, keep that in mind. So one of the lone pairs of oxygen have been used to form a dative bond with hydrogen. Okay, and we can see that over here it forms the hydroxonium ion, and the Cl minus ion is separated over here. So this is an example of dative bonding taking place in acid dissociation, and we can clearly see that the dative bond is between oxygen and hydrogen. Now why exactly this is happening? It is happening because the oxygen of the water molecule is electron rich and the hydrogen of the HCl molecule is electron deficient. Therefore, they would have the capacity to form a dative bond between themselves. Now, the next example that we will be studying is the neutralization reaction. In the neutralization reaction, we very well know that an acid must react with an alkali to form a salt, and generally also water. But if we take the example of aqueous ammonia reacting with hydrochloric acid, we would only have an ammonium salt as the product, and in this case it would be ammonium chloride. Now I have drawn out the structures to show the reaction, and in the reaction we can clearly see that the aqueous ammonia is reacting with the HCl molecule and it is forming the ammonium ion and the chloride ion, right? So now in this, how does dative bonding take place? Let's look at that. Again, we know that nitrogen is more electronegative than hydrogen, right? So the nitrogen would get a delta negative sign and the three hydrogens would get delta positive signs. So let's label that. And similarly, we already know, as we studied before in the previous example, that the hydrogen of the HCl would have a delta positive sign. Again, the nitrogen of the aqueous ammonia would pull the hydrogen of the HCl molecule due to the electronegativity difference and due to the lone pair that nitrogen already has. So let's draw a curly arrow to show representation of a movement of two electrons. Now similarly we have bonding electrons over here, both of which would go towards the chlorine. Now basically we can see that the nitrogen already had three hydrogens, but it has gained one more hydrogen, and it will gain also a positive charge due to the fourth bond that nitrogen is forming, and the Cl ion is separated over here. Now, basically, a very special case is this one of ammonium chloride, because there are three different kinds of bonds taking place in one compound of ammonium chloride. We can see that there are three single covalent bonds between the nitrogen and the hydrogens, right? I will mark them over here by writing 1. These are the three covalent bonds that nitrogen has with hydrogen. So this is the first type of bond. The second type of bond that we just studied was a dative bond forming between nitrogen and the fourth hydrogen. So I will mark that by the number 2. And the third type of bond is the ionic bond between the ammonium ion and the Cl minus ion. So that would be basically the bond between these two ions. So this is a point to note, that such a compound has three types of bonding in them: ionic, dative, and simple covalent. And that is all for this video. And in the next video, we will be studying Al2Cl6 dimer and the dissociation of water. Thank you.